right. This is the end of the lessons for linear inequalities, and we're going to end off with graphing. So some of the things that I wanted to remind you of that we have encountered when we were at earlier units are in my key ideas. And I wanted you to remember that when you have x is equal to a number, it means that it's a vertical line. Think about vertical jump. Think about basketball players, football players. If they're at the combine, they often measure their vertical leap. So it's up and down, right? Y equals is your horizontal line. Think about how the sun comes up, and when you look left to right, that's called the horizon, right? Because it goes across the y-axis, whereas the vertical line goes across the x-axis. Then I also wanted you to remember that when you're looking at slope-intercept form, it's a slanted line. It's either going to slant from left to right as you read, like rising from left to right, or it could be falling from left to right. But you always read from left to right when we're talking about slope-intercept form, and there's some type of slant to that line. Now, when you're graphing, I think, and I hope that you would remember our conversation about open circles versus closed circles, because there's a connection here. When we're talking about graphing inequalities, when we were graphing a single inequality on a number line, we often used open circles to denote that the value that was under that open circle was not included. Well, the way that we show that a value is not included when we're graphing inequalities is the fact that we're using a dotted line. If we wanted to show that a value was included, we closed the circle, right? So not included, open circle, right? Included, closed circle. Now the closed circle here goes along with what we call a solid line, because we're saying, yes, include this value. Now the other things that I want you to remember, we're going to run through this pretty quickly because I want to go ahead and graph so that you can see what it looks like. When you're graphing and x is greater than some value, that means that all of your shading will be to the right of that line. So you're going to shade everything to the right of that line. And you'll see what I mean in just a moment. If x is less than a value, then you're going to draw your line, which is going to be dotted, and you're going to shade to the left of that line. If you have x is greater than or equal to a value, you're going to draw a solid line, and you're going to shade all the values greater than a. So you're going to shade to the right of that line. If it's less than or equal to, then you're going to have a solid line, and you're going to shade all the values to the left of that line. Now, when it's y is greater than, remember that's going to be your horizontal line, you're shading above or beneath. So if it's y is greater than a, then you have a dotted line on your value of a, and you're going to shade everything above it. If it's y is less than a, you're again going to have a dotted line, and you're going to shade everything under it. If it's y is greater than or equal to some number, you're going to have a solid line and shade everything above it. If it's y is less than or equal to some number, then you're going to have a solid line and shade everything below it. Now, those are pretty easy, right? And I think that once you understand the concept of how it works with the slanted line, I think you're really going to love this. So when you've got a slanted line, right? So I'm saying y is greater than mx plus b. So I've got my slope-intercept form, right? And this line would be dotted because I'm saying don't include the value. And I'm going to say, well, all the values of y are greater than this line. And so what I said was shade above the line. Imagine this is a line. That means I'm going to shade on the top of it. If y is less than this line, and notice my slope is positive right here, then I'm going to shade everything below the line. Now, what happens when you turn the line and make it a negative slope, right? I said y is greater than this line. That means I'm going to shade everything above the line, right? And if y is less than this line, then again, I've got, now all of these were dotted lines. I didn't mention that, but I'm going to shade everything to the bottom of it. Now, what happens if we change from a dotted line to a solid line? Nothing really. As long as m is positive, I know I've got a positive slope, and all my values of y are greater than or equal to. That means I'm going to have answers on this line and above it. If it's y is less than or equal to, that means I'm going to have answers on this line and below it. If it changes and my slope is negative, but all my y values are greater than or equal to this line, I'm going to have answers all on this line and everything above it. Y is less than or equal to this negative slope, then I'm going to shade everything below it. Now, here's the difference between how we were shading before and how we're shading now. Remember, we just had just one number line, right? This time, it's all going to be about where the regions overlap. So once you graphed each inequality, and I'll show you that, you're going to have colors on one part, colors on another part, but where they overlap, that's where all of your answers lie. So let's go ahead and get into some graphing. All right, so here is our first attempt at this. We've got our first problem. That would have been a better way to say that, not attempt, because we are going to do this. I would suggest that you look at the symbols first and decide whether your lines are going to be solid or dotted. So what I know is that because I have a greater than or equal to sign, this line is going to be solid. And this is only a less than sign, so I know this line is going to be dotted. And I do that because I am notorious for just making everything a solid line when I know it should be dotted. So that's just a reminder for me. So what we've got is y is greater than or equal to -7. So we're going to come down to -7, and it's y, so I know I have to go across the y-axis. And I know I need a solid line. So I'm going to go ahead and put a solid line here. And what I know is that all of my values of y are greater than this line. So I'm just going to use color here. And I would suggest that when you're doing this particular lesson, use the graph paper that we have for you, or if you have access to the Inspire when you're doing it, go ahead and use the Inspire so that you can make sure that you're shading correctly. Now, the next thing that we've got to do is we've only graphed this top line. Let's graph the second one. X is less than 2. So we're going to come over here to 2, and it says X is less. So I know I have to go through the X-axis at the number 2. And I know that my line has to be dotted. Guys, forgive me. It's quite early in the morning. And so I think I'm starting to see things that are not there. Like the lines are all crooked to me. Okay. So I'm just gonna do it like this. And it says X, all my values of X are less than this line. So everything to to the left of this line is shaded. Now, your answer when you're doing our practice is only going to be this area right here. All of your answers that make this inequality true lie within this area. Not this area, because this only makes one of them true. Not this area down here, because this only makes the other one true. It's all of these answers in the double shaded area that make the inequality true. Let's move on to the next one. So we've got a double or two symbols here, so we know this is a solid line. Two symbols here, so we know this is also a solid line. We've got x is greater than -1. So here is -1. And I know it's a solid line. And all the values of x are greater than that line. So that means I'm going to shade this one. Now I have my slope-intercept form that says that, hey, okay, you've got a line that starts here at -2, and you're going to go down 4, 1, 2, 3, 4, and to the right 1. Or if you think about it, that's my rise. So I'm thinking, okay, I could go this way, but I could also say, since it's negative, I could go up 4, 1, 2, 3, 4, and to the left 1. Either way is fine. And again, that's a solid line. And it says that all of my values of y are greater than this line. So what I want you to notice here is that I have a little part that's shaded right here and a little part that's shaded right here. But it doesn't make both of the equations true. This only makes one equation true. This blue only makes one equation true. But it's where you see it start to turn green that makes both equations true. Okay? Look at these last two. So I know that this line, because it has a single symbol, is going to be dotted. This line is going to be solid. So I've got y is less than -4x plus 6. So I'm going to start with 6 here. I'm going to go down 4. 1, 2, 3, 4, and to the right 1. 1, 2, 3, 4. And I knew this was a negative slope because of the negative in front of the coefficient there. And I caught myself. I was about to just draw a solid line, dotted. And it says that all my values of y are less than this line. So go to the left or under it. And then we have our other line that says y is greater than x plus 3. So I'm going to start at 3 and go up 1 and over 1, up 1 over 1. This is a solid line. And all my values of y are greater than this line. So again, The only part that makes both equations true is in this area where you see both the blue and the yellow. Some of you may see it as blue and yellow. Some of you may say, oh, blue and yellow make green. However you see it. Let's do the final one here. Now what I suggest is that you take both of these equations and you change them to slope-intercept form. It's a lot easier to graph that way. So we've got 5x plus y is less than or equal to 5. We're going to subtract 5x from both sides of the equation. We've got y is less than or equal to negative 5x plus 5. So that one's done. And then we've got negative 3x plus y is greater than negative 4. And I'm going to add 3x, add 3x. Y is greater than 3x minus 4. So now it's just going to be easier to graph. But what I know is that this is going to be a solid line, and this one's going to be a dotted line. Okay, so we've got positive 5 as the y-intercept. We're going to go down 5 and to the right 1. Down 5 and to the right 1. Solid line. And it says all values of y are less than this line. So less than would be below it, below the line. And then we've got our other line, which is y is greater than 3x minus 4. So we come down here to negative 4. And we're going to go up 3 and to the right 1, up 3. And to the right 1. And this time, remember, it's dotted. And all values of y are greater than this line. So that means that I'm going to shade everything above it. I'm going to shade this one. And sometimes it helps to turn the paper so you can determine what's above and what's below. So again, the answers that qualify as solutions are found in this area right here. Okay, so as always, if you have any questions, please let me know. I'll be happy to help you. Have a great day.